Hey everybody, welcome to Practical Alchemy. On today's episode, we are going to be doing a little bit of spring cleaning and organization as I show you how to design your very own custom wrench rack that you can either 3D print or CNC. Now, for the past few weeks, I've been cleaning up my shop and organizing and creating a bunch of custom tool holders. And I was thinking to myself, this would make an awesome tutorial because number one, you're going to get something that's super useful out of it at the end. I've got this thing hanging on the wall, but you can very easily pop it off and sit it on the table. So really awesome. But more importantly, I think there's some really great modeling techniques in here that I want to show you so that you can continue to work on and improve your own modeling skills. So here's what we're going to do. We are going to be driving this off of two sketches. We're going to be using a lot of geometric relationships, and we are going to design this in a way that's going to make it very easy for you to modify it for different styles of wrenches, different sizes, different material thicknesses. We're going to set it up so that it's very parametrically modifiable, and also you can do a lot of customization on the back end. So this is going to be a really fun tutorial. We're going to make it really quick and just jump in. So first thing we're going to do is just clear everything out here and start from a fresh sketch. Now, I am using a 9 piece SAE kit for this, and you are going to have to take a few custom dimensions, but I'm going to show you just based off of that. So the first thing that we're going to do is create a sketch in the top plane, and as we always like to do, I'm going to start off with a center point rectangle that is going to act as my bounding box. Now, when we're looking at this wrench rack, what we saw was there are a bunch of little teeth essentially that are holding our wrenches in place. So the next thing that I'm going to do here is I am going to create a vertical line that is going to define those teeth. Now, this is essentially my layout sketch here, so let's start doing some initial dimensioning. So I know I want this to be 1.35 inches wide, and I want it to be 12 inches tall. And I know that I want all these little forks, I'm going to call them the forks, to be 0.35 inches deep. That's a little shallow. Let's do 0.5 inches deep. All right, great. So that's going to be the depth of my forks. So far, so good. Now, the next thing that we're going to do is we are going to start modeling in, and let's go ahead and turn this just so you're seeing something that's a little bit up close. We can turn it the other way. All right, so now let's start putting in our teeth, and we're going to do that by starting with a simple 3-point rectangle, and we are going to define the corners of this. So we know there's going to be one corner here on this surface. This is going to be my front surface or my front face. I know I'm going to have another corner here on this back line, and then my third is going to be floating out here somewhere. All right, great. So now that I've got that, that's going to essentially be my first fork. Let's add some dimensions here. So we're going to dimension that, and we are going to set the angle. In my case, I'm going to use a 45-degree angle, but if you feel like you need a different angle based off of your use case, you could certainly put that in now. All right, so in this example, I've got 9 wrenches, like I said, and in order to get a good fit, I think I want to do 3 different size rectangles. So let's go ahead and start off. Before we do any of that, let's add our other rectangles along the surface. And we're going to do this in the exact same way. So click here, and click here, and we're just going to very roughly lay these out. They do not have to be perfect, but what you do want to make sure is that they aren't accidentally aligning themselves to anything or snapping to any points that you don't want to define. So that's 5, 1, 2, 3, 4, 5, and 9. Okay, so with all 9 rectangles in place, the next thing that we need to do is constrain them all to this 45-degree angle. So let's click and select all of these rectangles. We're just going to select one edge, and we are going to set those to be parallel. So now you can see they are all going to be following the same angle. Hit escape to exit out that command. All right, so now because I've got these rectangles and I've got 9 different sizes of wrenches, I want to have a little bit tighter fit as we go up. And I'm going to do them in sets of 3. So what I want you to do is, if you're going to follow along with me here, I'm going to select these 3 and I'm going to make them equal in their width. Then I'm going to select the next 3, set those to be equal. And then I'm going to select my last 3 here, and I'm going to set those to be equal. Great. So now I've got 3 sets, and I'm going to start constraining those. So I pulled out my calipers, and I did some quick measurements and gave myself a little bit of gap here, just so there's not too tight. And I'm going to set this largest one, 2.375. Of course, your wrenches might differ, but as you can see, all 3 of these snap together. Then the next set of 3, I'm going to set 2.3, and the last set of 3, I'm going to set 2.25. All right, great. So that is all of our initial setup. The next thing that we need to do is we need to make sure that these are all spaced out equally to each other. So the way that we're going to do that is we're actually going to put in a few lines here. So from this corner to just be coincident there. All right. We're going to set those all to be along the horizontal line. And hit escape. Now what I can do is I am going to hold down the shift key to to select all of these lines. Then I am going to convert them to construction geometry, and I'm going to make them equal in length. And this is really cool because what you can see here is that no matter how far I set the gap between these teeth, I'm always going to have equal spacing between them. All right, so now what I want to do is I do want to add a little bit of an offset on the top and the bottom here just to make sure that I've got some material. So let's go ahead and set that. So let's say for this, I want to have a 0.5 offset on the bottom. And that's looking pretty good. And then maybe on the top edge, I want to have a 1-inch offset, something like that. That might be a little bit too big. Let's set that down to 0.5 as well. All right, great, looking pretty good here. And so now what you can see is it's given me the spacing in between my rack. Now I can delete this dimension if I want, and now I'm going to set the dimension between these spaces here. So I'm going to set this to be 0.5. All right, great. And so now you can see this has become much more parametrized, because if I increase this to 0.75, the whole thing is going to expand in width, right? Or if I want it to be a little bit tighter, I can close that down a little bit. All right, so if you come back and you say, actually, the first time I 3D printed this, these are a little bit tight in terms of tolerance, you can move that around. But this is looking pretty good for my starting point. All right, so now the next thing that we need to do is we need to put some spacers on this. Let's actually hit save really quick, just so we've got a save point. And I am going to come down here, and I'm going to create myself a little center line. Then I'm going to come here and create a rectangle. Let's give it a thickness. Doesn't matter what that is because we're actually going to change it. We're going to set the tab to be 1.5 inches. And we are going to offset it from the top surface by 1 inches. All right, great. So now that we've got that set, let's go ahead and mirror that across the mid plane so that we've got our tab on both sides. These are going to be the tabs that we're going to use to lock it into the base plate here. All right, so we're going to hit OK there. Great. And then what I want you to do is I want you to just put in a center line here, and we're going to add another one that goes out to there. Now, next thing that I want you to do is take these center lines, and I'm going to convert those to construction geometry, and we are going to save that for our next set of sketches for when we do our back plate. All right, so everything is set except for this one thing here, and this is going to be the material thickness of my back plate. So what I'm going to do is I'm going to come up here, change parameters. And I'm going to create a new user parameter here. So let's create a user parameter, and we are going to call this the back plate thickness. And let's set this to 0.25 inches and hit OK. All right, now I'm going to drag this over to the other screen so you can't see it for now. And then let's come back in here. And let's turn that into our backplate thickness. Hit enter. All right, so now you can see that that has updated. Let's hide some constraints here, and you can see what's going on. I've got my wrench rack with all of my different slots, and it's looking pretty good. So let's go ahead and finish that first sketch. All right, now the next thing that I'm going to do is I'm going to create the backplate, and this backplate is going to be driven by the primary sketch here. So let's go ahead and create a new sketch. We're also going to put that on the top plane here, and let's just rotate around so that we get a little bit more in our view plane. Now, the next thing I'm going to do is I'm going to create a center line down from the origin point so that I know that it is going to be centered, and turn that to construction geometry. Then create a rectangle. I'm going to do a center point rectangle. Surprise, surprise. I love my bounding boxes. And this is going to be my bounding box. Now, I know it's approximately going to be the same thickness. And then let's just set it to be about, usually about 5 inches here. So it doesn't have to be perfect. We're not going to dimension this because we want our uprights to determine the thickness of this plate. So now the next thing I'm going to do is go ahead and add another center line here. Great. And now what we're going to do is another 3-point rectangle that is going to go around this frame. So it's going to be a 3-point rectangle here, and we can imagine we're going to have one point that's somewhere around here, one point that's out here, and another point there. And this is essentially going to be the side view of this workpiece. So I'm going to constrain this to the bottom edge here. And now you can see that my rectangle is going to be inside of my frame. Now, what do I want to do here? Well, I want to make sure that this is going to be constrained to this length. So I'm going to select both of these. I can actually select things outside of the one sketch if you didn't know that, and I'm going to make that equal. All right, so now I can never change this length because it is always going to be equal to that frame. Okay, great. And then the next thing that I need to define is the thickness, of this upright. So let's click and drag out here. All right, and just hit enter. We are going to make this our second parameter. So this is going to be our upright thickness. Okay, and let's set this to 0.5 inches. Hit OK. And we are going to set that to be the upright thickness. Beautiful. And hit enter once you're done. Now, the next thing that we're going to do here is we want to put in some additional parameters before we mirror this across the other side. Notably, we need to add in this tab. So the way that we're going to do that is with a 3-point rectangle. So we're going to have 1 point here, 1 point here, and then our third point is going to go down there, but we're going to need to constrain it. For some reason, it doesn't want to constrain the third point. Very strange. And then I'm going to put a mid lane here, and then another midline here. Then I'm going to convert these to construction geometry. I think you can see where I'm going here. So I'm going to constrain this and this line to be equal in length so that I know that this slot is going to be the same as this tab. And then I'm going to constrain this line to be this length so that I know that it is the same distance from the edge. The next thing that I need to define here, I'm going to drag this out a little bit just to make it a little bit easier to understand what's happening, is I want to define the midpoint line of this arm because I want to use it to mirror this tab over so I don't have to define it again. So as you can see here, I'm going to scroll in and find that midpoint line. and convert it to construction geometry. And we can actually convert these into construction geometry now so that it's easier to see where the tabs are. Now, with all of that defined, the next thing that we're going to do is we are going to mirror this about the midplane. But before we do that, let's go ahead and add a constraint here. So this is going to be the upper and lower thickness of our wrench rack. So how far do we want these to span? All right, so in order to keep things from getting too wonky here, let's just define the offset distance here to be 8, just so we give ourselves a little bit of breathing room. And we're gonna set the distances of these uprights so that they angle in as the wrenches get smaller. So we're gonna use our measurements here to define what is the outer limit we wanna use on this side. And I'm going to take half of the distance that I need. So that would be 1.625 inches there. And then in order to pull this side in, I'm going to go here to here, and I'm going to set this to be 2 inches. And now you can see this is looking a lot more realistic. All right, so you can see that the only thing that is still unconstrained here is the thickness of the back plate. So I'm going to come in here and I'm going to set this. In my case, I want this to be a relationship to the outer edge. So I'm going to set this to 0.35 just so that it's always sitting outside of the outer edge of my uprights, no matter how the angles update. And then the last thing that I want to do before I finish, let's go ahead and take this one and convert it to sketch geometry, and we're going to offset it. So let's go ahead and offset this, and we are going to do an offset of, let's see, I'm going to do 0.02. All right, so I want this to be outside of that sketch there. And that is going to be my offset thickness. In fact, let's go ahead and make a variable for that. So we're going to call that our offset. And that is going to be the offset from the edge that I'm going to use to make sure that these two parts actually fit together. So let's drag this out a little bit, and I'm going to just call that negative offset and hit enter there. All right, so what that's going to allow me to do as we go to the 3D, right, is I know I've got this tab, and this tab is defined by its length and the thickness of the upright. I'm going to have a certain additional clearance that I want to put in here in order to account for that so that my parts can fit together if I'm going to 3D print them or if I'm going to CNC them. But this is a variable that I may want to change depending on that use case. So then I'm going to mirror this across my midline. So make sure that you select, they're very close together. It's a very shallow angle, so make sure you select that one. And now you can see that is reflected in my other piece. And then lastly, I'm going to mirror this across the center line. Grab all these edges, select my mirror line, that's here, and now you can see I've got my finished frame. And the majority of this is driven by the dimensions that I've captured in the upright sketch. So yeah, I can very quickly go back in and make those edits, and the rest of the model is going to update appropriately. And I know I'm going to have a perfect edge so that this thing fits inside of the frame. All right, now from here, things get pretty easy. All we have to do is extrude these two parts. So I'm going to come up here and I am going to extrude the frame and also the tabs. And I'm going to set that extrusion distance to the upright thickness and hit OK. Then I'm going to extrude this to my backplate thickness. And I'm going to hit OK. All right, and so then the last thing that we're going to do here is just a little bit of finishing and cleanup with some chamfers and fillets. So I want to put a chamfer right here and right here so that I don't have a really hard looking edge on the bottom of my rack. That's looking a little bit big, so let's go with maybe a 0.35. That's pretty good. And then I also want to fill it in all of these corners so that I get a much smoother entry into the rack shape. So it's going to be a little bit tedious, so I'm going to speed this up a little bit. All right, and let's give this a little bit of a fillet here. Just a hair, 0.065. And now I've got a nice little fillet on those corners that's going to ease the entry and exit of my fins. All right, let's come in here and add a little bit of color because these are looking pretty sad. And honestly, now we are pretty much done. From here, you should be able to snap these guys together and build out what I showed you at the top of the tutorial. Really what you're gonna do is either 3D print these out or you can CNC them out. And the uprights are just going to fit right into the tab, which you can then glue or screw in place. Now, this file is really designed just to be a starting place for you to open up your creativity from here. There's a lot of really cool things that you could do. So for example, maybe you were going to 3D print this. So I might want to do a quick shell here. And now I've got a more 3D printable design that's got a really cool kind of ribbed look to it. I might also want to put some markings in the top of this. So for example, I might want to add some text that calls out the fact that this is going to be the rack for my SAE wrenches. I'll drag that around a little bit and then extrude that up. And now I've got a nice little call out for the SAE. I might also want to put some keyhole slots in here so that I can hang it on the wall more easily. So you can grab a sketch line, find the midpoint here. Let's do a 3-point rectangle here. Line these two up. Finish sketch, and we will extrude that through there. So we'll do that as a cut. Hit OK, and now you've got a keyhole slot in the back of it. You may also want to cut this into 2 pieces just so that you could have it a little bit more 3D printable. So for example, you might not actually need this middle component here. So let's just create a quick sketch and we can drop out the middle, finish sketch. We're going to extrude this down so you can cut it out. That's fine. Now we've got 2 bodies. We've got a top and a bottom. Perfectly usable, and we could even shell this out as well. So we could make a cool looking shell, and now it's more of a 3-dimensional design. So there's some really cool opportunities for some creative solutions here. So definitely excited to open up the floor to you guys and see what you come up with beyond the basic design that I've got here. All right, so that is going to do it for today's tutorial. I hope you enjoyed it. If you did, leave a like. If you had any questions or topics you'd like to see in future videos, leave those in the comments section below. And as always, hit the subscribe button so you can stay up to date as I release new content. Thank you so much for watching, and I will see you in the next one. And don't forget to hit save.